Today we are going to talk about the basic atomic structure of an atom. The basic atomic structure of an atom is composed of the nucleus, which is the center of the atom and is home to the protons and the neutrons. The protons carry a positive charge and the neutrons carry no charge. And it is also home to electrons around it. And these electrons carry a negative charge. So we have the nucleus of an atom and the electron cloud. Now, we say that the electrons exist in an electron cloud because the electrons are constantly moving around. They're not in one set space. So the electron cloud is basically representative of any area that the electrons may be at any given moment. When you look at a periodic table, you will notice that there is a lot of information given. For example, you have here, that I'm writing out, the periodic table for helium. At the top, you have the atomic number. The atomic number. The atomic number will give you the number of protons in the nucleus of that atom. So if I have an atom of helium, I have exactly 2 protons in the nucleus. Next, I have the chemical symbol. And the chemical symbol is just a 1 to 2 letter abbreviation of the chemical name, and it's simply used for identifying the element. And down at the bottom, I have the atomic mass. The atomic mass is equivalent to the number of protons plus the number of neutrons. So essentially, the atomic mass is the mass of the nucleus of the atom. Now, in this example, you'll notice that the atomic mass for helium is 4.003. The reason why it's not an even integer is because of something called isotopes. Isotopes are molecules that have the same number of protons and it has the same number of protons, but a different number of neutrons. One example of a well-known isotope is carbon-14, which is used to date like ruins and stuff like that. So carbon-14 still has 6 protons and 8 neutrons. Carbon normally exists in carbon-12, which has 6 protons but only 6 neutrons. One common way of representing an atom is using the Bohr diagram. So we have a Bohr diagram. And the Bohr diagram basically sums up the nucleus by saying how many protons and electrons. So let's say we're doing the Bohr diagram for chlorine, which has an atomic number of 17 and a mass number, I'm just abbreviating here, a mass number of 35.45. Now, when you're doing the Bohr diagram, you're going to want to round the mass number up. So this 35.45 will round up to just 35. The reason we wouldn't round up to 36 is because of this 45. If it was 35.5 or larger, then we'd round up to 36. So basically your standard rounding rules apply here. So in black here, I have my nucleus, and I'm going to just put the number of protons and the number of neutrons in the nucleus. So my atomic number is 17, so I have 17 protons. And to calculate the number of neutrons, I take my mass number, 35, and I subtract 17 from it. 35 minus 17 is 18. So I have 18 neutrons. So that's the nucleus of my atom for the Bohr model. Now I have to do the electron configuration around it. So let me do this in a different color. So I have the first shell. Now the first shell can only carry 2 electrons at max. So I have 1 there and 1 there. My next shell can carry up to 8 electrons. So you start at the top and go clockwise. 1, 2, 3, 4, 5, 6, 7, 8. This brings me to a total of 10 electrons. So now I do one more orbital. And I do the same thing. So I have 7 more electrons. 1, 2, 3, 4, 5, 6, 7. And that would be the Bohr diagram. I know I need 17 electrons because I have 17 protons and I'm dealing with a neutral atom, which is just chlorine. And that concludes this video.